All right, we're looking at the 2021 Specialist Exam 1, and in this video we're looking at question 6. 4 marks there, so 4 marks. There needs to be a fair bit of working out to get your 4 marks. All right, so we've got 3 vectors, A, B and C, and C has this variable p, and you're told it is a real constant. All right, so the question asks us to find the values of p for which the 3 vectors are linearly independent. All right, so the strategy that we're going to use is we're going to look for when they are linearly dependent, the p for that, and then for independent it would be all the others, given that p is a real constant. All right, so this is one of the things that you need to have in your memory. So linear dependent. So linear dependent means that C would be some multiple of A plus some multiple of vector B. All right, and so I know that's going to give us, for dependence, but that's all we've got to work with at the moment, and I will explain at the end how we then get to the independence. All right, so if that is the case, then C is 3i plus 2j plus the absolute value of 1 minus p squared times k, and that is m lots of A, which is negative I plus 6j minus 3k, plus n lots of B, which is 2i minus 8j plus 5k. All right, so there we go. So that's for linear dependence, which is what we're going to start working with. Okay, so now we've got I, j and k components there, and what we're going to do is we're going to separate each of those. And so I'm going to look at the I component, the j component, and the k component, and I'll look at them separately. So for the I components, we've got 3 then, 3, and that has got to equal the combination from these two. So it's got to be negative m plus 2n. All right, because the 3i you've got to get from the combination of those I components from A and B. And the j, well, there's 2 lots of those, and we get that 6m and minus 8n. All right, then the k component, so the magnitude, absolute value, 1 minus p squared, can be negative 3m plus 5n. And so now we've got 3 equations there. All right, so what I'm going to do is I'm going to take this one and I'm going to times it by 4, that equation. And so when I do that, I get 12 equals minus 4m plus 8n. And the reason I've done that is because now with this equation here, this middle one, 2 was equal to 6m minus 8n. And so if I add those two things together, I get 14 equals 2m. And so from that, m would be equal to 7. All right, and so then to find what n is, I can use any one of these, but I'm going to use this one here. All right, the I component one, and so 3 then would be negative 7 plus 2n. So 10 is 2n. And so n would be 5. All right, so that now brings us to the k component, because I've used the I and the j components, and from them I've found out what m and n are. Now with our k component, if I'm putting m equals 7 and n equals 5 in there, then I find that the magnitude of 1 minus p squared would be negative 3 times 7, which is negative 21, plus 5 times 5, which is 25. So the magnitude of 1 minus p squared would be equal to 4. All right. So what does that mean? Well, if I then now remove these magnitude, so the magnitude of 1 minus p squared is got to equal 4. Well, if 1 minus p squared was equal to negative 4, then we'd use these modulus signs, absolute value signs, magnitude signs, whichever you prefer, and we would drop the negative. Similarly, if it was 1 minus p squared was equal to positive 4, well, we wouldn't have to drop anything, but that's okay, because that's what we're allowed. So 1 minus p squared could be either plus 4 or minus 4. So p squared then can be equal to 1 plus or minus 4. And I've done a couple of steps in one there. All right. So that means that p squared could be equal to, if it's equal to, sorry, I've lost my train of thought here. Plus or p squared is 1 plus or minus 4, and p is an element. So p squared of real numbers, so p is an element of real numbers. So because p is an element of real numbers, 1 plus 4 is okay, that's 5. But 1 minus 4 is not okay, because that's negative 3. And then if p squared is negative 3, we're then, to get p, we're trying to square root a negative. All right, so 1 minus 4 doesn't work out because p is an element of real numbers. So p squared can only equal 5, and so p then will be plus or minus root 5. All right, now this is for linear dependence. So linear dependent, so it's linearly dependent, these three vectors, when p is plus or minus root 5. Now in the question we were asked for independence. So if they're dependent for plus or minus root 5, then for everything else they must be linearly independent. So thus for linear independence, p could be any real number except for plus or minus root 5. All right, and so there's the solution for that particular question. All right, so what we've done, the strategy we've used is to find the opposite to what they're asking for, because we know a relationship between vectors when they're linearly dependent, and you need to commit that to memory, obviously, for exam 1. So we know that relationship, so we've worked with that relationship, found out what the P would be if they are dependent, linearly dependent, and so because P is an element of R, it could be anything else other than these two things, plus or minus root 5. Okay, 4 marker, so there needs to be a fair bit of work, or working out, I should say, shown for you to get your full marks.